Water cannot flow uphill. That is basic physics. So why did Roman engineers build aqueducts that appeared to do exactly that? The answer reveals engineering genius that modern scientists are only now beginning to fully understand. Here is the mystery that baffled historians for centuries. The Aqua Marcia, built in 144 BCE, carried water 56 miles from mountain springs to the heart of Rome. But the route was not a straight line. It twisted through valleys, crossed gorges, and at certain points appeared to push water directly up steep hillsides. Ancient writers marveled at this apparent miracle. Medieval observers assumed some kind of lost magical technology. Even early modern scientists struggled to explain what they were seeing. The water definitely reached Rome. The aqueduct definitely crossed terrain where downhill flow seemed impossible. So what were the Romans doing that nobody else understood? The answer lies not in magic or lost technology, but in something far more impressive, a mastery of mathematics and observation that would take humanity another 1,000 years to fully rediscover. To understand what the Romans actually achieved, we need to start with what they were working against. Gravity is relentless and unchangeable. Water flows downhill. Period. No ancient civilization could alter this fundamental law. But here is where Roman genius enters the picture. They realized that downhill does not mean obvious. A slope so gentle that the human eye cannot perceive it is still downhill. The Romans calculated that water would flow reliably along a gradient of just 1 foot of vertical drop for every 4,800 feet of horizontal distance. That is a slope of 0.02%. If you stood at one end of a football field with water flowing toward the other end at this gradient, the far end would be less than 1/4 of an inch lower. Completely invisible to the naked eye. Yet the water flows. This is not defying gravity. This is understanding gravity with precision that most people cannot even perceive exists. But here is where it gets truly remarkable. Think about what measuring a slope of 0.02% actually requires. You need to detect elevation changes smaller than the width of your finger across distances of miles. In an age before lasers, before GPS, before even reliable glass lenses, the Romans did this using an instrument called the chorobates. And when archaeologists finally reconstructed one based on ancient descriptions, they discovered something shocking. It worked. Beautifully. The chorobates was essentially a 20-foot-long wooden beam with a narrow channel carved into its top surface. You filled this channel with water. Water, being water, always finds a perfect level. By sighting along this dead-flat water surface toward distant markers, Roman surveyors could detect elevation differences that would be invisible any other way. They turned water itself into their most precise measuring tool. And this leads us to perhaps the most impressive part of Roman aqueduct engineering. The Pont du Gard. This three-tiered bridge in southern France carried the Nîmes aqueduct across the Gardon River Valley. It stands 160 feet tall. It spans 900 feet. It was built from 50,000 tons of precisely cut limestone blocks. No mortar. Just perfectly fitted stone. And across that entire massive structure, the water channel maintains its gradient with an error margin of less than 1 inch per mile. Modern laser surveys have confirmed this. The Romans achieved accuracy that approaches the limits of what is even meaningful to measure. But here is what makes it truly mind-bending. The Pont du Gard was not some special showcase project. It was municipal infrastructure. A water pipe. The Romans built to this standard routinely because they had figured out systems and methods that made this level of precision reproducible. What would you think if I told you they had an even more impressive trick for when valleys were too deep for bridges? This is where everything you think you know gets turned upside down. When Roman engineers encountered a valley too deep for practical bridge construction, they did something that looks completely impossible. They sent the water down into the valley and back up the other side. This is the inverted siphon. And this is precisely why observers throughout history believed Romans had somehow made water flow uphill. But here is the breakthrough that changes everything. The Romans were not defying physics. They were exploiting physics in a way that requires deep mathematical understanding. When water flows down a sealed pipe into a valley, it builds pressure. Enormous pressure. At the bottom of a 300-foot drop, water exerts a force of over 130 pounds per square inch. That pressure pushes the water back up the other side. As long as the outlet is lower than the inlet, even by just a few feet, the system works. Gravity is still doing all the work. The Romans simply understood how to redirect where gravity pushed. But understanding the principle is one thing. Building pipes that can withstand 130 pounds per square inch. That is an engineering challenge that would test modern manufacturers. Lead was the Romans' material of choice. They discovered that lead could be cast into sheets, rolled into tubes, and soldered together with remarkable precision. But even lead has limits. At the bottom of deep siphons, where pressure peaked, Romans used stone pipes reinforced with lead linings. They developed standardized pipe sizes. They created inspection access points. They built header tanks to regulate flow. This was not primitive experimentation. This was systematic engineering. The aqueduct at Lyon in France used 9 different siphons along its route, some plunging over 300 feet into valleys. Each one required precise calculations of pipe diameter, wall thickness, and joint reinforcement. Get any of these wrong, and the entire system fails catastrophically. But wait until you see what happened when we tried to recreate their methods. In 2007, a team of French engineers decided to test Roman methods by building a working siphon using only materials and techniques available in ancient times. They cast lead pipes. They calculated